So we're going to look at lesson 8, Sprite properties. You can see that in this lesson we're going to be learning some new code, some new dot notation to code the properties of our sprite's rotation. That's the direction that they face. The scale, which is a much easier way to resize a sprite than going back into the animations and actually resizing. And setting specific locations, X and Y coordinates on the screen. The property, the term property means a label for a characteristic of a sprite, such as its location and appearance. So today we're talking about how we can use sprite properties to change their appearance on the screen. In the very first one, you are to make a prediction, very first or second bubble, I should say. And it asks you, what does the program show? I want you to make your own prediction there. Think about it. I'm going to move on to bubble 3. Bubble 3, we're looking at, let me double check and make sure that I have started over. Pretty sure I did. So in bubble 3, we want to run the program to see where the sprites appear. Okay, so we have a palette and a brush, and what we want to do is change the X and Y properties so that the paintbrush is actually on or touching the palette. So it makes a scene there where they're touching each other. So right now, the palette, which is this thing down here that has the paint on it, is at 100, 300. So 100 over, 300 down, puts the center of that palette right there. And right now the brush is at 300 over, 100 down. And we want to move the paintbrush down here. We could set it to 100, 300, exactly like the palette, but I don't know that that's going to look the best. Let's make that adjustment. Let's see what happens. Yeah, see that I don't really like the way that looks. I think it would look better if the paintbrush was up, maybe dipping into the blue or the red, looking like it's actually going to paint something. So we're going to go up, maybe if this is the center, we want this part to go up 50, maybe 75, and over 50. So by up, we take away. So let's do 225, and maybe increase this to 150. See how that looks. Oh, very close. In fact, let's just bring this down to 235. I think that looks pretty good. And it doesn't have to look exactly like mine. The instructions just say to move the paintbrush sprite so that it moves to the palette, which is what we did. Okay, moving along. You can see though that we can adjust the X and the Y separately using that dot notation. All right, for bubble 4, we're going to look at some new properties called scale and rotation. And we have a drum set. And the first 2 notes, all of the notes are the same sprite, the little 8th notes here. And they have been created, but you can see that notes 1 and note 2 has some special scale and rotation dot notation there. And then you see notes 3 and 4 do not have any extra. So they're just straight up and down, kind of big. And we want to use the rotation and scale blocks in the last two notes to make them look different. So let's look at it. So note 1 scale is 0.3, note 2 scale is 0.7. So I'm thinking that if it's less than 1, it's going to be a smaller size, but the closer we get to 1 whole, the closer it gets to the original size. So you can see 0.7 is closer to 1 whole, so it's going to be larger than 0.3. Let's test that theory out and drag a scale over to note 3. And we're going to need to name it note 3. So let's try 0.5, which should be in the middle of those two sizes. Yes, it is. And then we'll do one more for the last one. We'll change the scale. Uh-oh. Try that again. I want it to go under. There we go. Note 4. And how about if we make it maybe a little bit smaller, 0.8. And I notice it says a leading decimal point can be confused with a dot. What that means is I should put a 0 in front of the decimal so that they don't think it's a dot notation thing. All right, so note 4. So we've done part of it. We've changed our scale using our scale blocks. Now let's look at rotation. Rotation, things move in a circle. I know that that is measured in degrees. So I'm thinking that this number has to do with a certain amount of degrees. So note 1, 20 is a positive number, whereas note 2, the rotation is a negative. So if straight up and down is 0, then this one's tilted this way when it's positive and tilted to the left whenever it's negative. So let's do another positive one for note 3. And we'll name it note 3. The last one was 20. Let's name this one maybe 45. Oh yeah. So you can see it's at a 45-degree angle there. I'm going to do the last one with note 4. And this time I'm going to tilt it in the opposite direction. So a negative, last one was negative 30. Let's do a negative 10. Yeah, let's do 15. I'm afraid it's too small, it might not be noticeable. Okay. So we have done what we needed to do here. Finish. Alrighty, so now that we know a little bit about using scale property to make the animals, or now we can make the animals the right size by simply using that dot notation. So when we first run this, oh, the animals are way too big. And scale of 1 is normal size, scale of 2 is twice as big, and scale of 0.5 is half as big. So for us to be able to make our pictures look the same, we need our elephant and our cow to be smaller. So let's maybe make the elephant, I'm going to say It doesn't look that much smaller. I don't think he's half the size, but we can try half and see what that looks like. Same thing with the cow. We can start there. And the cow looks about right, but the elephant should be a little bigger. So let's make it maybe 0.8. And that's pretty close. You can see the fingernails showing a little bit here and the fingernails showing a little bit there. That's close enough. I would say it's probably could go down to 0.75 to be more exact. Yeah, there we go. Now the fish. The fish is just a little bit too big, I think. Maybe. Then again, actually the fish looks, yeah, it's a little bit too big. So let's make it maybe 0.75 as well. Pretty close, but it's still not all inside that blue bubble. So let's make it 0.5. That will do. And then our fly is way too big. The fly should be the smallest thing on this screen. 0.5, let's start there. Oh yeah, that looks about right now. All right, make sure the fish fits in the pond. It does. Each animal is as big as it should be. Okay. Looks good. Finish. For bubble 6, it is the assessment level, so I'm not going to do this one. Oh, wait. Rotation property. Almost forgot. We still have one more in bubble 5. So in bubble 5B, rotation property, you want to rotate. Right now, the cars are sort of facing in weird directions, and we want them to face the right way that traffic should drive in America, since that's where we live. So normally when you are out driving, you drive in the right-hand lane in that direction. So the headlamp should be facing that way. And anybody coming towards you in that left-hand lane should be facing in the other direction. So that's what we want to look at. So if we look over here at the picture, it will help us out there too, if you forget. So the green car does not need to change. The red car needs to rotate from being facing straight up to facing to the right. So let's read what it says here. The dot rotation sprite property rotates an image between 0 and 360. The image is rotated clockwise. For example, my sprite dot rotation equals 90 will turn it 1/4 rotation to its right, which is what we want to happen to the red car. So let's go find the red car. That is the car that's on the left. It says car red. And we want to use the rotation property here. We need to make sure that we change that to match the name, car left. And we want to do what the instructions suggested. Let's make it 90. Let's see if that works. Boom. So now you can see our red car and our red car are correct. Green car still matches. Our blue car is driving on the wrong side of the road. He needs to turn around. So let's fix him next. I know if this was 90 and we want to keep turning it another 90 degrees, another quarter turn to be able to face it the opposite direction. So that would be 180. All right, so let's go down here to the blue car, car bottom. And let's try 180. Yes, that worked just fine. Now, a little trickier might be this yellow car, which is not as far turned as the red car. So if straight up was 0, we want it to face between 0 and 90. So I'm going to drag this one out here, the rotation. And let's think about what would be a good number between 0 and 90 to try. Well, if you are thinking in your head 45, then you read my mind. Let's see how that looks. Looks like the picture. And we can now see that we have made all the cars look like they are traveling correctly down the roads. Now we'll look at the assessment level briefly but you'll do it on your own. All right. In this one, the food's too big to fit on the plate. You want to make this food smaller using the Sprite properties to scale the food down so it fits on the plate. Just so you know, to get a 100 on this particular assessment, we want it to look virtually identical to the example provided in the instructions. So if you make them too tiny, or there's still some noticeable differences between your work and the example, it will not quite get a 100. However, if it is resized to fit on the plate in the circle, you'll still get a 90 for the convincing evidence. But let your goal be to try to get it just like the one in the example. All right. Looking at the challenges, this is looking at a new block of tint. And I'm going to go over these real quick because I had a bit of a challenge with this one. When I first did it, I wasn't sure what to do. The instructions that were not very plain, and helps and tips does not help much here. But this is what it said. Tint is like putting a pane of colored glass over the top of the Sprite. So the existing colors are still there, but now we're going to tint them maybe a different shade of blue or red or something like that, using either the Sprite already created. So here's our Sprite. Play around with the tint property. So all of the Sprite properties are under Sprites. We're going to drag tint over here. And remember, our Sprite is called creature. And I had trouble with this one because I wasn't sure. I was like, well, should I just type in a color? And it tells me blue hasn't been declared. So when I do this, nothing happened. And I will tell you that I learned we need to put it in quotation marks. There we go. Now you can see that our creature is now tinted blue. If we think that that's too dark, we can tint him light blue. And all of the same colors that we have used before that are part of the color wheel like they have in W3 schools, any of those colors, you're welcome to go see W3 schools. And aqua was one. There we go. That's pretty. And we could even pull out some other animations. And maybe let's go back to our crab friend. Oh, I need to create him. So let's grab $300, $200. And we want to grab set animation to crab. And I know he's going to be too big. So let's just see how big is he. Yeah, he's way too big. So I'm going to go ahead and scale him down some. Yeah, let's do 0.5. Better. All right, so we have a crab. He is already red. So when we color him, if we were to color him red, probably not going to see too much difference. Oh, his eyeballs turned red. But you can see he stayed pretty much the same. What about if we do blue? Remember, that's like putting a blue pane of glass over him. That's weird. He turned black. Now his eyeballs are blue because they were white before. Let's try light blue. Okay, now it's like a darker shade of red. So depending on the starting color of your sprite is going to depend on how much of the tint is going to show through and how it will impact. If you see it like this, then you know that the color you're using is probably too dark of a color. Let's see. Let's try yellow. My logical brain wants me to think that that will make it orange. And maybe it is a little more orangish, but it's not as orange as I would have thought it would have been. Is there a light yellow? Yeah. So anyway, play around. If a sprite has lots of white places, then the tint will be much more obvious. If the sprite is a lot lighter in color. If it's a very bold color like this crab, it's a little harder to tint. All right. Finally, the last one is adjusting the height and width blocks. And so normally when we use the scale block, which is normally the preference to resize something is to use the scale block, it keeps the height and width proportional. So your creature doesn't look too stretched out or too wide. But maybe we want this giraffe to look a little taller. His neck isn't tall enough for us. Or we want to resize him to fit in a specific spot, and maybe his proportions are not all that important. So now we can adjust the height and width. Right now, this giraffe, if each one of these are 50s, this is 100, 200. He's 300 tall and about 150 or so wide. So let's say we want to make him maybe 200. Well, actually, let's make him as tall as the whole. Let's say we want to take up the whole screen, 400. Now you can see he's still the same width. He did not change, but he changed disproportionately. He's taller now than he was, but he's still the same width. In this case, with a giraffe, it doesn't look terrible. If we take the grid off, he still looks pretty giraffe-like, just with a longer neck, stretched out a little bit. And so that's one way to change the size. If the proportion mattered, you would not want to do it that way. But you can also adjust the width. Let's say we want him to look even more stretched out. We might say only make him 100 wide. Now you can see he's even taller and skinnier. All right. Play around with that and figure out that a little more. And that is all for this lesson.